Hello everyone. In the previous demonstration I was showing you how to use I was using RPi-4B with a CM-550 color tracking using OpenCV, but it was a Python version. In this demonstration it's a C++ version. So the interfacing is slightly different than from the Python version. So this time I'm going to use an LN101 hook up to the RPi-4B, and then also I'm using the ZIGBEE SDK of Robotus. The rest is the same. We're tracking some color with the USB cam hook up to the RPi-4B. So let's see. So in the Python version, in the previous version of the demonstration, I was just using a custom LN101 cable from the CM-550 to the GPIO port of the RPi-4B. Okay. So when we did that, we were using Thonny and PYSERIAL, and the device of course was dev serial 0 at 57K. In the C++ version, I'm actually using an actual LN101 hooked up to the USB port of the RPi-4B, and just using the standard LN101 cable, not cut up or anything, goes on to the UART port of the CM-550. And the tool chain on the RPi-4B now is different. I'm using code block for the IDE and using the Robotus ZIGBEE SDK. They happen to have the Linux version 1 with it. So this is code in CPP that already shown in my volume 1 book, and I'm going to use it, and we'll find out it's some little modification, and you can use it on the RPi-4B in Linux. So first thing, of course, is the window.h is not used anymore on Linux. And when you use the Linux ZIGBEE SDK, these are the 3 include files that you need to have on your code, so they are put there. Also, you need to download ZIGBEE SDK from the Robotus website, and I unzip them to this folder here on my home folder, ZIGBEE SDK. Inside you're going to see that 4 folders. Go to the source folder, so I have it here. Go to the source folder, and that 2 files that you need to check or modify depending on your situation, how you use your RPi-4B 4B ZIGBEE how.c. In that one there, you need to check on the device name, how you want to call it. Okay, so I'm using LN101, and this happened to be the only USB TTY USB device there, so mine is TTB USB 0, so we are fine. So the %D here eventually will become 0. So who knows, depending on your situation, you may have TTY USB 1 or 2. Okay, so that you need to check on that. So by default, the Linux ZIGBEE SDK is set up that way, so that's good for my situation. The next one you need to do is also in the same folder, the source there, src. You need to check zigbee.c. In zigbee.c, that's where you set up the baud rate. In theory, you can have it at 115K, but so far I haven't tried yet. I'm just staying at 56.7K now. So if you change this one to, let's say, 115K, you have to make sure that on the CM-550 you have to go through the manager tool and change it to 115K, so that the baud rate match up between the RPi-4B and the CM-550. That of course goes without saying, right? Okay, and then once you check sure that everything you're happy the way you want it, and then there's a make file on the same source folder, and you need to make the new library. They're going to give you a new libzigbee.a, and then that's the one you specify and use in the code blocks and stuff. Okay, that minimal code changes between the PC and RPi-4B versions. I show you what. So on the PC version, they use the string name port number, and then for example, if you use COM17 on Windows and you just put the number 17 there, the timeout is still 1000 milliseconds. On the RPi, however, they call it different. They use it device index. So make sure you change that to device index. And then because I have TTY USB 0, so I just use 0 index there. Timeout is okay. Also be very careful when you use the ZIGBEE SDK. There's a bunch of functions, and make sure you change default port number to default device index. If not, you know, it couldn't find the right variable, the right constant. On the up down arrow, remember in Windows they give this constant, these kind of integer that correspond to the up, down, left, right arrow. On Linux they are different, so they are these numbers instead. This one we already showed in the Python version also. Okay, so I'm still using VNC server on the Pi and VNC viewer on the PC to do development and to the control of this project. And here's a demonstration video, so you can see a little bit background there. That's how the code blocks IDE looks like. So we're using the same. So this is live video. This is the original target frame, and it's open to isolate only the blue block. And this is my console running here. And you're gonna see two demos. First, I have the robot speed set at 50. And I found out that still a little bit too fast. You're gonna see this video and thing a lot smoother if you compare that versus the Python version demo I made before. So the image coming a lot quicker now that I'm using compile C. And 50 is still too fast though. And then in the second part of the demo, I'm gonna slow it down to 40. But then and also show you how I manually set it up so that I can extract the ROI and track it. And also I show you there is some problem with my lighting. Suddenly my open target disappears, so I have to turn on the local lights and then recalibrate everything, and then it's tracking okay again. I will comment more in this video coming along. So right now it's here, so let's do it. Hello everyone, this is just a quick demo showing you the C++ version. I'm using code blocks on an RPi. You see it's running right now, everything is tracking. So let's check it. So I just move it to the right side, and you see the robot right now is on autonomous mode, so it's trying to track. And you see it moving a little bit too fast now. That's why you see it coming back and coming further away too much. It's jiggling around too much, but it's doing its job, I guess. See the speed on the robot right now is at 50, so it's kind of high. So I'm stopping it now. I'm going to switch the speed to a bit lower. Here I'm showing you the process of adjusting it. To extract the ROI. So I'm lining up the ROI manually right now through the keyboard. Yeah, I'm using the keyboard to move it up and down. You can see that up the ROI area completely blue. Now I push E. It extracted out the data. All the hue looks decent. Okay, so I put on track. So it's tracking now, and it's tracking happy there. So let's see, I'm going to move it closer. So when I'm moving it closer, you can see the robot trying to back away to get the same number of pixels again. But then the lighting changed, and you can see I lost my open target frame. Couldn't get back again. So I just turn on the light, so you can see the background is more bright now, but the background get darker because of contrast. Because the video camera is on auto light. I'm resetting, so I'm resetting everything. I'm going to recalibrate, and I'm going to try to put in the position again. bit closer. Looks good. Extract. Let's see. Extract OK. We should be able to track now. Okay. Tracking good. Yeah, funny shadow down here. It's probably going to affect it. We'll see. Yeah, turning too much. Still running a little bit too fast. So I lost it. So I had to bring the object back into view. Yeah, the speed is a lot better. It's set up to 40 now.